Okay, here we're going to calculate the mean and standard deviation of a set of data that is represented using a frequency table. So here we have some scores. We have scores of 1, 2, 3, 4 and 5, and then we have their corresponding frequencies, so how many times that score was scored or how many times it appears in the data. So there's 1 1, there's 2 2s, there's 4 3s, there are 2 4s, and there is 1 5. So it's quite a small data set, but we're going to use frequency table approach to do it. So going to start with a longhand method. I'm going to use the mean of the squared deviations approach. So I'm not going to do the mean of the squares minus the square of the mean. I'm just going to say the variance is the mean of the squared deviations and the standard deviation is the square root of the variance. So we need to find the mean to begin with. So if we make a little table here, so x and f, so I'm just going to copy this. I don't need to do it. We could do it like this, but I'm going to do it anyway. So 1, 2, 3, 4, 5, 1, 2, 4, 2, 1, 1, 2, 4, 2, 1. So then we're going to need an fx column. Fx, remember, just think mean when you're really young, in one of the lower years, basically. The mean is the total score divided by the total frequency. So the total score, well, there's, for this score of 1, only one person got there. There's only one piece of data for 1, so that's going to be 1 times 1. The 2 2s gives a total score of 4. 3 4s, or sorry, 4 3s will give a total score of 12. 2 4s are going to give you 8, and 5 1s, or 1 5, is going to give you 5, right? So then if we have this sort of a sigma column, we're going to need the sum of the frequencies. We're going to need to know the sum of the frequency tells you how many bits of data there are, and then the sum, or the sigma fx, tells you the total score. So this will be total score, and this will be total frequency, how many bits of data. This is your n. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's very nice. So n equals 10. The sigma fx is 1, 5, and there's another 5 there, so that's 10, plus the 12 and the 8, which is 20. So 20 plus the 10 must be 30. So that means your x bar, or your mu, same thing. Well, it's just the sigma fx over n, which is 30 over 10, which is 3. So our mu is 3. Got that. Then we need to work out the standard deviation. As I was saying, I'm going to do variance as the mean of the squared deviation. So I could extend the table, but I think in terms of clarity, I think it'll be better if I just do another table. So if we have our x's, which were 1, 2, 3, 4 and 5, 1, 2, 3, 4 and 5, then we can have our, well, I would always write x minus x bar, but looking at the formula sheet, it is x minus mu, so I'm going to write x minus mu instead. You will notice I'm going to use sort of x bar and mu interchangeably a lot. They're the same thing, really. I'm sure a proper statistician will tell you maybe they're not the same thing. They might relate to samples or whatever, but when I interchange them, they will be the same thing. So x minus mu is just this number, take away 3, as mu is 3. So 1 minus 3 is minus 2, 2 minus 3 is minus 1, 3 minus 3 is 0, 4 minus 3 is 1, and 5 minus 3 is 2. So then, remember that the variance is the mean of the squared deviation. So I still need to square the deviation. So x minus mu, or x minus x bar, squared. So I just need to square these numbers. So that is going to be 4, 1, 0, 1, and 4. Let's fill in this table a little bit. And so then we're going to have to work out the mean of these. So we need the mean of the squared deviation. So I'm going to need f x minus mu. So x minus mu squared. So I'm going to need to, well, I've got these squared deviations, then I need to multiply them by how many there were. So I could potentially have done with an f column in there, but never mind. I will use these f's in here. So I need to multiply the 4 by 1. 4 times 1 is 4. The 1, this had a frequency of 2, so that would be 2. The next frequency was 4, so 0 times 4 is 0. The next frequency was 2, so 1 times 2 is 2. And the final frequency was 1. 4 times 1 is 4. It's written 1 there. So now I'm going to need sigma, so I'm going to need to know the total, and then I'm going to just divide it by n. 4, 6, 7, 8, 9, 10, 11, 12. So the mean of the squared deviations, which is sigma squared, must be 12 over n, 10, which is 1.2, which means that sigma must be the square root of that, square root of 1.2, which comes out at 1.095. So to 3 significant figures, we'll call that 1.10, and that is your standard deviation. Now, just showing you how we can use it, how we can use technology in a frequency table. So I've already plugged in the list 1, list 2, which should save a bit of time. So on the Casio, you go to menu and statistics. As I was saying, I've already put these numbers in. So 1, 2, 3, 4, 5, and 1, 2, 4, 2, 1. I've done it on the TI as well, hopefully. So we go stats and edit. I've got list 1 and list 2 filled in. So that's if I put the raw data in. Then what we need to do, so on the Casio you're going to go calc, and you're going to go to set, and you need to tell the calculator that it's a frequency table. In fact, I need to tell it that the X list, as in the actual variable, which, remember, the variable in this is score, that was covered in list 1, the first column, so that needs to say list 1. It says list 2 at the moment. List 1. One variable frequency, well, it's not 1. If that would be 1 if you had a list of numbers, e.g. if every one of these scores had a frequency of 1, but it doesn't. I need to tell it that list 2, as in the second column, I need to say that is the frequency list of list 1, so I need to say that's list 2. So for any frequency table, if you're working out means or quartiles or standard deviation, any of that stuff, list 1, list 2. So on the TI, we go stats and we go across to calc, 1 var stats, because there's only one variable, score. And we want the list to be L1, just the same as this actually. So we want the list for the variable to be L1, so second, and then we L1 is in 1. And the frequency list, there is a frequency list, it is L2, so second 2. You can see the L2 just there in blue. Enter and calculate, and on the TI, sorry, not the TI, on the Casio, we need to go execute and 1 var. Hopefully they give the same numbers. So x bar, which we said was mu, the mean is 3, which agrees with our figures. And sigma x is the standard deviation, 1.095, 1.095. Don't worry about the rest of the numbers, but you should really use the n equals 10 to check. Now, if you had not told this was a frequency table, n would be 5 for the 5 columns there.